Hello, welcome to the thousands of listeners. My name is Urmas Alber and I am the BIM and Asset Information Management Coordinator. My main focus actually in this company is building up a proper asset register to share the information among the stakeholders. Nowadays, that sharing should be done by more advanced tools than Excel files, because Excel is not a database, but GIS is a database. And I will talk about it more closely. All my contact data is in the QR code, which I will show you at the end of the presentation also. But when you replay it later, then you can get my information also. First, most important is the terminology. I am not going very deeply into defining what is BIM. You can read about it here, and some of you have listened to the previous sessions where Andy mentioned it, and also Jovita Staranina, but she did that in Lithuanian language. The definitions of BIM are also rather different. For example, the United Kingdom Roads Liaison Group has defined BIM as better information management. And actually, I like that definition a lot, because for me, BIM is actually the whole project. And nowadays, there should be no difference what is a BIM project and which is a regular project. Today's agenda, there will be three main sections. First, I will tell about BIM and the standards. Why are the standards important? Then in more detail about asset information and asset register, that there is some difference. And the third part, actually covered during the whole presentation, is that sharing is caring nowadays. First, about the standards. There are traditional questions that we should answer during whole projects or whatever we do. Who, what, where, when, and why. Why somebody needs what kind of information, where and when. And then if we know answer to that, then it comes to the questions, what information do we have or do we have to create, and where it should be located. So everybody who needs that information can access it. Standards are the common language. I found here a nice picture about the traditional picture about boats being fruits, but it really depends on the people what they understand, what is a fruit and what is not, or is apple and orange one and the same. Some examples are actually, I will show you more pictures from the real life and from the environments than just traditional presentation, because that proves that we have done something in real life also, and we do not have just theory. Actually, it took me a lot of time to coordinate the names of our design sections, for example, and making everybody understand that it's really essential to use the same names and codes everywhere. Here is another example how the data is connected, namely if we have properly written down the codes of the submission packages here, then we can get a proper list of the objects that belong to that package. And if that information is properly systematized, then we can edit the data and update everywhere. For example, in GIS, there is nice editing interface, not exactly Excel, but as close as it gets. You fill in the dates, the times, and you see then the reports in the environments. Pay notice also to the ID codes that we are using. I will talk about them a little bit later. It is also very important that all people understand the locations and the names of the railway stations or railway stops. So again, coordination of those names took a lot of time, but now we have them fixed and everybody is using those. And when the information is properly structured, then it is not difficult to display all kinds of fancy summary reports where you see which objects we have, where they are, and what are their different statuses. So you filter some objects on the map and then get respective reports. So you do not have to create some additional PowerPoints or sending the PDF files to your colleagues. Here is one example of the classification that I draw on the paper to explain that we have different types of objects. We have the railway crossings, we have some piles, we have some traffic lights. Each of them will have the peer code, which is one of our attributes in design guidelines. We have also the type number for that, and we have the units. We also need always a dictionary connecting our standards, our codes to other codes. For example, in Estonian road administration, nowadays it has a different name, it's traffic administration. They have their own code for the geotextiles, for example. But if we have those two codes in our database, we can always create the reports that each party requires. Below is a little example. For example, we have 235 square meters of textile type 1, geotextile type 1, and textile type 5, we have 326 square meters. Based on that, we can create one report that shows us different types of textiles, and the total numbers I could not calculate manually by hand, so I used the computer. So real summary is real total is 561 square meters, to be precise. And the other report shows us just this Uniclass code, the geotextiles, how many square meter we have that. Based on that, we can arrange tenders and compare the information, meaning all the tenderers do not have to measure the areas on site, but they get it from the database. Actually, we have multiple classification systems in our design guidelines. Why we have so many? It's mainly for the validation reasons. So you can compare one classification to other and see if something is missed or not. The most important code is in design guidelines is written air bare walls is zone, but it does not tell to a normal human being anything. So we will use now the term site, meaning one object, a bridge, a road, or a part of the track is one site. And this site has multiple objects, whether there are pillars or railings or traffic lights. Each element should be unique on the site. And the combination of those codes will be then unique code for that particular element among the whole railway line. Now to the peer code, which is the Uniclass code and the type number. And we have also one additional code there, units, meaning we can measure, for example, the asphalt layer in cubic meter, in square meters, and also in tons. But it should be clear what we have written into our database. So the combination of the peer code or the Uniclass code and type number is really important for all our tender documents. Because that element is in the models, and also we will call the tender and require 500 pieces of, for example, this type of element. Then we have discipline codes like architecture, structure, geodesy, and so on. That is mainly for the documentation purposes. And we have invented our own codes for object classification. This is a rather temporary code which enables us to move over later to the peer codes system. Because in many cases, at the beginning in the value engineering phase, it's difficult to decide which Uniclass code we should use. But in case we use the object classification code, then pillar is a pillar always. And if you choose now the textual part of the object ID, which is the set out seed, so generally the name for it, then that is used here in the unique element part. Initially in our design guidelines, or actually it's written up to date that we want to have here a number, but we do not mind, or actually we prefer if we have there some human readable name. So instead of having 6 or 7 digits along, when you see that set out seed, meaning it's some seeding area, and you understand immediately what we are talking about. We gather the information, the basic information about the sites, and after that we will move on to systematizing the maintenance info according to the element types. Because already in the design phase, the designers provide us with the maintenance instructions. And our aim is to get all that data in a structured manner into the database. So if we select certain types of elements, we know which is their suggested maintenance schedule. And we are doing it by using Uniclass 2015, which is set in our design guidelines, but a very interesting collaboration process is going on right now, the construction classification international collaboration. You have the website here where we will have, or actually the first version is already there, of the standard that will be applied hopefully in the Nordic countries, in Baltics, and also Poland and Czech Republic, meaning the countries located very close to us. Next topic is about asset information management. Now back to the picture with what I started. It is really difficult to convince the people that first that Excel is not a database, And the second challenge is to tell to the people that GIS is a database. So I try to convince you in that also. Hopefully I succeed. So to keep the information systematized and sharing that is the database. And here is the example screenshot from our web interface, where we have imported the data about the assets that we have, and we have also their geometrical information. And now I show you the picture from the database, meaning really those assets that we have here, the asset geometry table and information here, that is actually in real Microsoft SQL Server database, which we can query then using the database tools, or we can use the tools that are available in the GIS environment. Because in addition to the traditional database, the geodatabase has the option to create spatial joins. For example, in this particular case, we have some construction sections, which is the red line here. And then we have sites that are located along it. But there are multiple construction sections. And if we perform a query in GIS, then we get the report, we get the data, the report, and that report can be shown directly in the environment. For example, we create spatial joins to get a list of sites in environmental assessment area, and we can show that report directly in the application. Here, for example, we see the list of the crossings that are in certain environmental environmental impact assessment areas. In Estonian language, it's KMH. And you can show that those reports in real life to the real people. No PDFs, no PPTs, no XLSs. Now it's a really foggy picture about the structure of the basic tables in the database and the relationships there. I will just zoom into a couple of tables. For example, the site table, we have the information about the site, and the sites are connected to the assets, to the asset geometry, and so on. So we have the structured data. Next slide is about the asset register. When we compare them, what is asset register and what is asset information management, then asset register is based on the design deliverables. And the objective of it is to systematize basic information of assets. That is mostly static. But during the life cycle of the project, we are gathering information. And the objective of the asset information management system would be then efficient and effective life cycle management of the assets. In other words, having the OPEX under control. So back to the left column, the basic information is the unique ID of the asset. The location, of course, its name is rather useful, but the important are the types and then the maintenance instruction for each type, which I mentioned earlier. But during the life cycle, also some additional information is gathered. For example, in the construction phase, we do not perform any maintenance actions, but we have the installation date, we have the producer's information, we have the warranty information. And of course, the handover info contains a lot of information, so the dates, the owner, the responsible persons or responsible organization, etc. And all that leads us to the RAMS management, or RAMS, learn that acronym and the definition of it: reliability, availability, maintainability, and safety. And especially safety is utmost important in railway management. Now, when we move to the column on the right, then what we do during the life cycle of the project. Based on the data that we gather during the construction phase and the phase before it, we can calculate the real maintenance and inspection schedules. As I am new to the railway, and I think most of you are also, then I bring the example from the buildings side. For example, the maintenance schedules for the ventilation filters. Depending where your building is located, on the countryside or in the middle of the city, the time for changing the filters might rather differ. So if the manufacturer says that you have to change the filters every year, then in some places you have to do it every 3 months. In some places annually is sufficient. We plan a maintenance workflow in a maintenance system. There are 4 different maintenance workflows. The most newest one are on the top. First of all, the prescriptive maintenance. If you listen to Andy's presentation from a couple of days ago, he talks about prescriptive analysis. Then we have the predictive maintenance, we have preventive maintenance, and the traditional reactive maintenance, meaning if something goes wrong, then we fix it. I hope we will never get to that, but we have to be prepared. Then in the real life, we track also all kinds of metered information, whether it's the electricity consumption or the tracks passing certain point. And that leads us to the real RAMS implementation, meaning we define the RAMS parameters for each types of objects, and then we implement the procedures defined there. Next slide comes from the presentation of my good colleague Vaidas, who is our GIS expert. And you can take a look at those points later on. Here is the information how we are using GIS in our company for which purposes. Now back to the theory of the books and the books. Paul Teichholz has participated in creating of those 2 great books. They are not about the railway, but principally information modeling and managing. It's not so different whether you manage a horizontal structure or a vertical structure. And what he described on page 6 and 7 on the first book is actually proven also in my experience, that in the design phase, the graphics are very important, meaning 3D showing all the details. The further we move on in the life cycle, the less important the graphics become. For example, for the maintenance guy who goes to fix a pipe, then for him it's rather important to know in which room that particular pipe is, or at which kilometer that particular sleeper is, what he has to fix. He does not care so much about the nice 3D picture of that sleeper. Oh, better information management. Our railway is based on three whales. The common data environment, which is for which we are using the Bentley ProjectWise system. And right now the asset information management, or actually asset register at the moment, are in ArcGIS. Back also to the first slides in my presentation, that the whole project actually is BIM, meaning BIM model is not just 3D. 3D is just one part of it. We also have 2D drawings greater than that. PDFs, the instruction manuals, for example, the quantity takes off that are taken from the model but amended with data out of real life. All kind of different documentations, and also the scheduling and planning. All of that is BIM model, so the whole project is BIM. That is what says also our BIM manual, that you have to gather the information when it is becoming available. I have shown this slide for a long time. As you see, it originated from year 2005. But still it's really difficult for people to understand that information, or actually they understand that information gets lost during the different phases in life cycle. But still they do not do much about it. So therefore we are here stressing the importance of having the data in the database, so we do not have to start recollecting the information in the next phase. And you see the gap is the biggest between the construction and the operations. Now some practical slides or practical use of BIM and GIS integration in real life. Land acquisition. In Estonia, lots of information that is top secret in Latvia and Lithuania is publicly available. So the Estonian land port, from Estonian land port, we can get the geometries of the land acquisition or land plots. So those are there in blue. And we have imported the model of this particular aqueduct into GIS, and we see that this aqueduct is very nicely placed on the land that is already acquired to the state. And the red dot over there shows the information about that aqueduct, the general information that is coming from the database, to which design priority section it belongs, what is its name, in local language. Next slide shows about the problems that we have discovered during that merging of land plots and models. The red arrows point to the gray areas, meaning land plots that are not acquired yet, or about what we do not have any information. So, but our design is located in there, so there may be issues. So therefore, to get more information about the land plots, or not the land plots, but the assets that are located on those land plots, we click on them and we get information about those assets in there. Next, more summarized information about the importance of the coding is that we all must follow the same logic when coding and sharing that information. For example, here we have different levels. We have the information on country level. We have the information about the design section. We should write the codes in a proper way. And for example, the submission packages in here, you have those codes written properly, and the site codes. So for example, if we put the Lithuanian design section 1, priority section 4, and submission package 3.2, then everybody can find it in their systems. We put a lot of emphasis on integration with other systems that are used. So the documents are in Bentley project-wise, also the incoming and outgoing documents, the models, the date, the drawings, the documentation, technical specification, all that is in project-wise. And we are about to develop an interface, which is in pilot phase right now. If we click on the object in the model, then we see the detailed data, or we see the documents then in GIS. We do not have to go into the project-wise environment. The second integration is with Oracle Primavera P6, which is the scheduling software and maintaining, monitoring the schedules that we have for the deliverables, for construction, and so on and so forth. The deadlines, the forecasted deadlines, the baselines, and so on. So people are happy to see the numbers, but people are even happier to see, for example, those construction sections visually, and then see the dates next to them and paint the lines then red, green, or yellow based on the numbers that show how good we are doing. I mentioned also earlier the names and IDs. So it's really important to have one name for the object that everybody uses it. Here is one example of one bridge. Where in a very quick speed, I created at least 6 different names for the bridge. And as you see, we have their nice fancy letters that are not available in every language and on every keyboard. And the greatest joke is the name of the municipality for the foreigners. And I have seen that Häädemeeste spelled also in 5 different ways. And also only with lots of imagination, I could decode that it was Häädemeeste. But every person is able to write down 2 letters and 4 digits. So it's principally like the PIN code, and it's also easy for the computer then to compare that data. How we gather the information. On the first picture, you have here the information from the GIS database. Here you have the Excel information because it takes a lot of time to edit lots of numeric data in that GIS interface, but it goes in a rather fast speed in Excel. So I asked all the project managers and their assistants to fill in the Excel tables. And then I imported those Excel tables into the system. And as we are dealing with real people, then for real people, it's really difficult to understand that BP08 is not the same as BP-08 or BP8 or just 8. Because if we want to connect the information in database, they should be used in exactly the same format. But people understood that and produced very nice tables, and because of that, we can now show that information on the map as I demonstrated earlier. The submission packages Excel-like editing is what I showed you already in the beginning. If the information is already in the system, then it's not difficult to edit one date for this particular package here, which has actually 24 sites assigned. So you just update one number, and next to all those 24 sites, that date will be updated. So it goes much faster than in Excel, and there are much less mistakes. If the information is in the database, then people who are used to Power BI can create any reports based on that. This is not real life data. This is just some dummy data to demonstrate that we can draw lines based on the database information. And again, this slide that I showed in the beginning, we get from the database the correct codes of the objects. So we zoom in, we see where they are in real life. And as I showed you, the 3D information also is available there. We can filter that data, and we can see the situation of different submission packages. We can get the overview how good we are doing with land acquisition drawings, for example, as shown here. And we see here how many objects are in master design phase out of the selected, and so on and so forth. So that leads me to the last slide, which is very popular nowadays, that if you share the information with people, all our lives will be much easier. And we accomplish much more than sitting individually, keeping my data just to myself. It is really important to share that in the organization and giving everybody the possibility to take advantage of the data that is provided by the colleagues. And you can get my contact data from this QR code right now. So that will be actually the whole presentation. Now I am looking forward to your questions because we have some time left. Thank you. Let me see if we have any questions. One question is how complies State Construction Control Bureau system, for example, in Latvia, how does that system complies with requirements with RB BIM? That is actually the difficult task that our designers have to solve because in their contracts they have declared that they will provide information in accordance with the local authorities' requirements and with our requirements. Why is it important to follow our requirements? Is that we have the whole railway line, and it's really important to gather the information in a systematized way. And so far, if the requirements are different, then just two different sets of documents are created by the designers. I hope that answered the question. Another question, do you think that construction companies are able to take advantage of the BIM information? Yes, they can. I am more and more optimistic because the development in that area is really fast, and the construction companies understand that this knowledge is really needed. I am more acquainted with the information or the situation in Estonian construction companies. Most of them have their BIM directors nowadays with different names, BIM top manager, BIM director, whatever. But they really put a lot of emphasis of updating the BIM information. If they don't know it by themselves, they outsource that knowledge from the companies that can support them. And so far, this has been very successful, I would say. For example, in construction of that Saustinõmme bridge, we got really nice as-built models. Yeah, that was that. Anything else? If there is nothing else, then I hope that my colleagues will tell me when to say goodbye. Now I got the information. There are no more questions. So thank you all for attention. I hope the presentation was useful. I scrolled rather fast through the topics, but you can review that later and contact us if there are any questions we could help you with. So thank you very much.